Manufacturers use premium materials, including high-grade steel and copper, to ensure durability and efficiency. Components are engineered with tight tolerances to ensure optimal performance and longevity. The process incorporates state-of-the-art machinery and robotics for consistent quality. The stator and rotor cores are made from laminated silicon steel to reduce energy loss and improve efficiency. Copper wires are precisely wound around the stator slots using automated winding machines. Each coil is insulated with high-quality materials to prevent electrical shorts and enhance safety. The windings undergo a vacuum impregnation process to ensure complete insulation and prevent moisture ingress. The rotor is assembled with high precision to ensure balanced rotation and minimize vibrations. Rotors are dynamically balanced to ensure smooth operation and reduce wear. Motors are subjected to high-temperature tests to ensure they can operate under extreme conditions. Designs incorporate features to minimize operational noise, enhancing user comfort. Motors are designed to meet stringent energy efficiency standards, reducing operational costs. Each motor undergoes rigorous quality control checks at multiple stages of production. Manufacturing processes are designed to minimize environmental impact, adhering to strict regulations. Motors can be customized to meet specific requirements, including voltage, frequency, and power ratings. Comprehensive testing ensures motors perform reliably under various operating conditions. The combination of quality materials and precise manufacturing results in motors with extended lifespans. Manufacturing processes comply with international standards, ensuring global compatibility. Japanese manufacturers continually refine processes to enhance performance and reduce costs. A highly trained workforce is integral to maintaining the high standards of Japanese manufacturing. Advanced automation is integrated into the production line to increase efficiency and consistency. A well-organized supply chain ensures timely availability of high-quality components. Ongoing R&D efforts focus on developing innovative technologies to improve motor performance. Manufacturing processes adhere to strict safety standards to protect workers and end users. Each motor is traceable throughout the production process, ensuring accountability and quality assurance. Lean principles are applied to minimize waste and optimize production efficiency. Feedback from customers is integrated into the design and manufacturing process to meet market demands. Manufacturers maintain transparency in their supply chains to ensure ethical sourcing of materials. Some motors are designed with energy recovery systems to improve overall system efficiency. Computer simulations are used to model motor performance and optimize designs before physical production.